Hello viewers, welcome to Add-on. In this question, we are going to discuss about diode clamper circuit with suitable example. Okay, one second. Yeah. So we are going to discuss about clamper circuit, right? So what is a clamper? Clamper is a device, or we can say electronic device or electronic gadget that will clamp the DC level of our input signal to a different DC level, or we can say to a desired DC level. For example, let us suppose I have a signal here. Okay. So I am assuming that the peak DC level of this signal is 5 volt. Okay. This is the peak DC level of this signal. Now, as I have said in the clamper circuit, we can clamp or shift the DC level of the input signal to any desired DC level. So, what we can do? Suppose I want to shift this signal from 5 volt to 10 volt. Okay. So I am assuming that this is a uniform or symmetric signal. So this has 5 volt peak amplitude in the positive half cycle, and this has minus 5 volt peak amplitude in the negative half cycle. So what I'm trying to do is I'm going to shift this DC level from 5 volt to 10 volt. So our signal at this point will look like this. Okay. This will be our signal now. So what I have do here? So what I have done here? Suppose this level, I'm writing is where this mark. Suppose this level, this is our zero reference point or ground level. And here it is also zero reference point. So I am trying to move this peak amplitude from 5 volt to 10 volt. Okay. So here we can see I have just shifted this minus 5 volt. Okay. I have just shifted this minus 5 volt above the reference level. Okay. So this, suppose in this scenario, this 5 volt is now the, we can say this now has become the reference level of this sinusoidal signal. Okay. So if we draw the reference line like this, so this is our 5 volt line, which was this peak amplitude in this signal. But now as we have clamped or shift the signal in the upper side or in the positive y direction, so this minus 5 volt have shifted over the zero reference line. And as a result, what happened here is this 0 to 5 volt. Okay. So this gap is what? This gap is 5 volt. Okay. As I have shifted this minus 5 volt above the zero reference level, so this negative half cycle, this particular part is minus 5 volt. They are minus 5 volt. And this positive half cycle part, this was also 5 volt. Okay. So this positive half cycle part, this is also 5 volt. So this is 5 volt, this is 5 volt. If we combine them together, what is the peak amplitude here? This is 10 volt. So we have successfully shifted the DC level of this input signal from 5 volt to 10 volt. So this is our basic requirement of a clamper circuit. Now this clamper circuit are basically of two types: positive clamper and negative clamper. So as the name suggests, the positive clamper will shift in the upward direction, as I have denoted here, and in the negative clamper will shift in the downward direction. Okay, below the reference level. So we are going to draw the circuit diagram of both positive clamper as well as negative clamper to visualize how this clamper circuit work. Okay, so let us move a free space here. Yeah. So first of all, we are going to draw positive clamper. So the circuit of positive clamper is like this. Okay. So this is the circuit diagram of the positive clamper. Sorry, I think this here, this diode, the position of the diode will be like this. Okay. So this is the circuit diagram of a positive clamper, right? So what happens in a positive clamper is, during the positive half cycle of the AC input supply, during the positive half cycle, this is the P terminal and this is the N terminal. Okay. So what happens in this clamping circuit? Sorry, this is completely wrong. Negative clamper circuit. This is the negative clamper circuit. So sorry for the mistake. So during the positive half cycle of this AC power supply, what happens is that this P terminal, this is connected to the positive end of the battery. And this N terminal, this is connected to the negative end of the battery. So during the positive half cycle, the current becomes shorted within this particular loop. Okay. So what happens is that we are using a capacitor here. So when the current gets shorted within the loop, the capacitor gets charged up to the peak value of this input AC voltage. Okay. Suppose the peak value is Vs. So the capacitor gets charged up to the peak value of this input AC voltage, right? And during this particular time, if we measure the output voltage across the load resistance, we won't get any kind of output. Okay. And now, when the diode is reverse biased, so the opposite scenario arises. Suppose this is the reverse bias condition. So during the reverse bias, what happens? That this is the negative terminal of battery, this is the positive terminal of battery. So during this time, this P terminal will connected to the negative end and this N terminal will be connected to the positive end. So during this time, the diode become reverse biased. So as the diode become reverse biased, the diode will act like a open circuit, right? This will be the load resistance and this will be the output here. Okay. So what happens during reverse bias? The diode will become open circuit. The capacitor was previously charged up to the peak value of the input voltage Vs. And when we are measuring the output across this load resistance, this charge which was stored previously in the capacitor will discharge itself into the load resistance. So we across the load resistance, at first we will get a voltage of Vs, and the voltage which we are applying here, which was also Vs, this voltage, we will also get this voltage across this load resistance. So total voltage we will get is Vs plus Vs is equal to 2 of Vs. Okay. So as this occurs during the negative half cycle of the input AC supply, so the clamping will be done in the negative direction. For example, this is our input signal. This is the peak value of voltage Vs. So if we use negative clamper here, the signal will be like this. Okay. This is clamping in the negative direction. If we consider this point as the zero reference point, this is the zero reference point. So the clamping we can see, if this is the peak value Vs and this was the peak value minus of Vs. So now the clamping will be like this. Okay, in this direction. So this is now the reference level. This value is Vs. This value is Vs. So total voltage in this total peak voltage in the negative half cycle is minus of 2 of Vs. Okay. So we have done the clamping. So we have done the clamping in the negative direction. Okay. So this is the principle of negative clamper. Now we will discuss about positive clamper. Okay. So we will discuss about positive clamper now. Yeah. So positive clamper. So the positive clamper is just the same as the negative clamper, only the position of the diode will be changed. So this is our supply, this is our capacitor, this is our diode, this is our load resistance, and across this load resistance, we are taking the output. Okay. So during the positive half cycle, so this input AC supply, this is the AC supply. Suppose it has a peak value of Vs, so it has positive half cycle as well as negative half cycle. So during the negative half cycle, I am considering the negative half cycle scenario at first. during the negative half cycle, what happens? This N side and this P side. This P side is connected to the positive terminal and this N side is connected to the negative terminal. So this diode will become forward biased. Okay. So as the diode becomes forward biased, current will flow within this loop. Okay. We won't get any voltage across the out. So during this time, this capacitor, I am terming it as C, this will get charged up to the peak value of the input AC voltage, which is Vs. Okay. So this occurs during the negative half cycle. And now during the positive half cycle, what happens? This N terminal, this polarity become plus and minus. So the N terminal will connect it to the positive end of the battery and the P terminal will be connected to the negative end of the battery. So this connection scenario will make the diode reverse biased. So during reverse bias, the diode will act like a open circuit like this, as because the diode will not conduct and no current will flow through the diode. So now, if you want to measure the voltage across this load resistance, this is V out. So this capacitor was previously charged up to a value of Vs. So this capacitor will now discharge itself onto the load resistance, and this input voltage Vs, we will also get this voltage across this load resistance, because the voltage which we are getting here is also the voltage which we are getting here. Okay. We can see as this circuit is open circuit, no current is flowing, the current just passes like this. So the voltage which we are getting across this input power supply is also the voltage which we will be getting across this load resistance, plus the capacitor discharges itself onto the load resistance. So the total voltage becomes Vs plus Vs is equal to twice of Vs. Okay. And as the as we are getting the output voltage during the positive half cycle, so the clamping will occur in the positive direction. Okay. So if we draw the waveform of it, suppose this is the input voltage, input supply. This is Vs, this is minus of Vs. So if you do the clamping in the positive direction, the signal will be like this. The signal will be like this. So if we consider that this was the reference point before 0, so this reference point, okay, which was present there up to that, which was present there in the input waveform, this reference point is now at this position. And in this particular waveform, the original reference point is this. So this was 0. Okay. So now this was 0, this was minus of Vs. Okay. So now this 0 reference point has moved up to this position, and this minus of Vs point has moved up to this position. So in this point, in this particular figure, this reference point, this is 0. Okay. Because this was the reference point in the input waveform. So in the output waveform, the reference point moves at this position, and this point has a value of what? Minus of Vs. Okay. So this is this is Vs. Okay. So this, if we calculate this particular portion, this has a value of Vs. Similarly, if this reference point is 0, which is similar to this reference point, then this part is what? This part is Vs. So this part will be what? This part will also be Vs. And if we calculate the total amplitude of this particular point, this is what? Vs for below this reference line and Vs above this reference line. So this amplitude will be what? 2 of Vs. So we have done the clamping in the positive direction. So this is the principle of positive clamper. Okay. I hope we can all understand the working principle of clamper. Thank you.